ERA1 is a tool I built to measure USB HID latency, how long it takes from a physical button press to the moment the USB report arrives at the host. The tool works, data comes out. But that raises an obvious question. How do I know the numbers are right? Any tool can produce numbers. The question is whether those numbers correspond to something real. To answer that, I needed a reference, something independent that observes the same physical event from the outside, without relying on any software or hardware inside ERA1. ERA1 runs on a microcontroller configured as a USB host. The device under test plugs into ERA1, not into the PC. When ERA1 runs a latency test, it drives a GPIO pin through an optocoupler to close the button contact on the device. It captures timestamp T1 at that moment. When the USB host firmware receives the matching HID report, it captures timestamp T2 in the interrupt service routine. Latency is T2 minus T1. Both timestamps come from the same Cortex-M cycle counter. The PC is not part of the measurement. The reference I used is a Beagle USB 480 protocol analyzer. A Beagle sits physically on the USB cable between ERA1 and the device. It records hardware-level timestamps for every USB packet, data, ACK, everything, independently of any software on the host. It sees what is actually on the wire. The Beagle is the closest practical reference for USB timing without a dedicated oscilloscope with USB protocol decoding. I tested 3 gamepad models across 5 configurations: GulaKid ES Pro wired, Razer Wolverine V3, Pro 8 KPC in wired and wireless modes, and FlyDigi Apex 5 in wired and wireless modes. 1,000 trials per configuration, 5,000 matched pairs in total. ERA1 and the Beagle ran simultaneously. After each run, I matched ERA1's trial log to the Beagle's packet log by order and button bit pattern. Then I calculated the difference. Here is what ERA1 measured for each configuration. Raw reported latency from button press to USB report arrival. The ranges are wide. A wireless device at a lower polling rate can swing several milliseconds between its fastest and slowest samples. That is expected. That is real device behavior, not measurement error. Now the important part. For each of those 5,000 trials, I calculated ERA1 minus Beagle. How far was ERA1 from the hardware reference, sample by sample? Each bar shows the full range, minimum to maximum, across 1,000 trials for that configuration. The dot marks the median. Across all 5 configurations, ERA1 was between minus 0.5 and plus 2.3 microseconds, relative to Beagle data end, 5,000 trials, all within plus or minus 2.3 microseconds of a hardware USB analyzer. The correlation between ERA1 and the Beagle is greater than 0.99996. ERA1 does not just average close to the reference, it tracks the same trial-by-trial variation the Beagle sees. Based on this dataset, ERA1 supports a conservative accuracy specification of plus or minus 5 microseconds. 2 honest caveats. First, this dataset covers gamepad configurations only. Mouse and keyboard have not yet been validated against a Beagle reference. Second, ERA1's accuracy depends on a well-characterized crystal oscillator. Clock frequency tolerance matters for timing, and individual boards should be verified. ERA1 measures what it claims to measure: 5,000 trials, 3 gamepad models, all within 2.3 microseconds of a hardware USB analyzer.